Lesson 53, adding and subtracting polynomials. So we're going to start with what a monomial is. So this is a vocab word. Monomial has whole number exponents on the variables, and it is a product. So we're going to do some that are monomials, some examples of monomials, and some examples that are not monomials. So a monomial would equal x. I mean, that if you had x, that's a monomial. 3 is a monomial because the variable has the exponent of 0. We have x cubed divided by 2, that's a monomial, negative xy. So these are all monomials. Here's examples of, oh wait, I was going to do one more. 0.75x squared. There we go, 0.75x squared. Okay, here's examples of not monomials, x minus y. This is a difference and not a product. A monomial is just a single term all by itself. So 2 divided by x is not a monomial because the exponent on x is a negative 1. So that's why it's not. We need whole number exponents. Another one would be 0.75x to the negative 2. That is not a monomial because it has a negative exponent. Now we can find the degree of a term or of a monomial. And the degree is just the sum of all the exponents on the variables. So it's the sum of the exponents on the variables. So I was going to do some examples here. So we're going to list some monomials, and then we're going to list the degree of those monomials. So if we just have x, the exponent on x is 1, so the degree is 1. If we had the number 3, the degree is 0 because the exponent on x is 0. Anything to the 0 power is 1. 3 times 1 is 3, so the degree is 0. X, y squared, z to the 4th. Now, even though you can't see the exponent on x, there is still 1 there, and it's a 1. So you add 1 plus 2 plus 4, which is 7. So that has degree 7. 4, x squared, y, z. Oops, I was going to square the 4. Now, the definition of the degree is just the exponents on the variables that you add up. So we don't count the squared on the 4. We just count this squared and the 1 and the 1. So that has degree 4. Now, a polynomial is a sum or difference of monomials. It's like our expressions where we had terms that were separated by plus or minus signs. When you have that expression and there's plus or minus signs between them, that's called a polynomial. So we have different names. Some polynomials, we already know that the monomial, here's an example, it has 1 term. A binomial has 2 terms. It could have a plus sign or a minus sign between it. Trinomial is a type of polynomial that has 3 terms. So they're terms that are added or subtracted. This is an example of a trinomial. All other lengths of polynomials, so if you had more than 3 terms, we just call those polynomials. And there's an example, it has 4 terms. So even though these binomial, trinomial, and trinomials have different names, they're still polynomials. They're just type of polynomials. Now let's say we wanted to find the degree of a polynomial. To find that, you have to find the degree of the greatest degree term in the polynomial. So the degree of a polynomial is the degree of the term with the highest degree. So let me give an example. We have this is an example, 2n squared plus n cubed. So we want to find the degree of each term. So the degree of this term is 2, and the degree of this term is 3. The highest degree is 3, so the degree of the polynomial is 3. So it's just the one with the highest degree. Here's another example. Eight x y squared minus 9 plus 5x cubed y cubed z. So we're going to find the degree of each term. You add up the exponents on the variable. So this is 3. There's no variable here, so it's 0. And this one is 7. So the degree of the polynomial is 7. Now we can put polynomials in standard form. So standard form for polynomials, the way we do that is we order the terms from greatest to least degree. So let's just use the polynomial that is that we have right up here above when we did another example. So the highest degree term was the last one. So we have 5x cubed y cubed z. And then the next one is a positive with the degree 3, so it's 8x y squared, and then we put the last term that has a degree of 0. And that's in standard form. So in order to put it in standard form, you have to be able to know the degree of each monomial. So we're going to do this one. Okay, so the leading coefficient. Okay, if you remember, a coefficient is the constant that is on the exponents. So the leading coefficient is the coefficient in front of the greatest degree term So if we looked at our example right up above, we put it in standard form. I should put the greatest degree term when the polynomial is written in standard form, because you have to have it in standard form to find the leading coefficient. Oh, actually, I guess it doesn't have to be in standard form, because if it's the greatest degree term, you can find the coefficient of it. Usually we want to put it in standard form, and then we know it's just the very first constant. So in this case, the leading coefficient is 5. Here's an example where we want to find the leading coefficient. So let's see, plus 8. Let's see if this is in standard form. This has a degree of 4. This is 3, 2, 0. Okay, so it's in standard form. The leading coefficient is 3. I want to do one more, and that's where we have, we're going to have 23 x y z minus x squared y squared z plus 5 xy z squared. Okay, so we look at the degree terms. This one has degree 3, this one has degree 5, and this one has degree 4. So the greatest degree term is the one that's 5. We want to keep the sign with it. So it's negative x squared y squared z plus 5xy z squared plus 23xy z. So now we look to find the leading coefficient. We look in front of the highest degree term and find the coefficient. Well, if we don't see a number, if you remember, that's a 1. So the leading coefficient is a 1. I mean a negative 1. Woo! It's a negative 1. That's the end of the lesson.